This review video is going to go over solutions, and we're going to start with a review of a lot of vocabulary words. So I'll try to shorten the definitions as much as I can. The first one is homogeneous, which means mixed uniformly. So this would be something like a mixture of Kool-Aid that is going to taste the same regardless of which glass you poured it into. Once you make a pitcher of Kool-Aid, it's all going to taste about the same. The difference would be heterogeneous, which means not mixed uniformly. So this would be something like a salad. So I might get 2 tomatoes and you get 1, so it's not necessarily the same throughout the entire salad. The next word is solute versus solvent. The solute is the thing that gets dissolved. So if you were making salt water, it would be the salt, and the solvent is the thing that does the dissolving. So if you put it into water, a lot of times water is the solvent, not always. If water is the solvent, we have this fancy word that means dissolved in water. A few more words you need to know are saturated, which means it's holding the maximum solute under those conditions. And then we can talk about the phrase like, dissolves like. And this refers to polarity. So we talked about the fact that polar things can dissolve other polar things, nonpolar can dissolve nonpolar. Here, we'll go ahead and write out a few of them. Polar dissolves other polar. Nonpolar dissolves nonpolar. And then if it's ionic, you're going to use the solubility rules. So the main thing to remember is that if something is polar and something else is nonpolar, they're likely not going to dissolve. We also did a solubility curve. And this is the one that has just kind of lines going all over the place. We'll just draw a whole bunch of things up here. And this is showing you the grams dissolved in 100 grams of water. And then down here is going to be the temperature. So it allows you to look at a lot of different chemicals and see what it takes to make them saturated. So if you are on the line, it's saturated. If you find a dot that is going to be on the line, that means it's saturated. Under the line means it's unsaturated. And then above it would be supersaturated, but that's a difficult thing to achieve. So we usually focus on saturated and unsaturated. Keep in mind that we have to set the amount of water constant, because if you change the amount of water that you're dissolving it in, it would change how much you can dissolve. So they usually do the graph for 100 grams of water, so you just have to be careful in the question. First of all, it says 100 grams, then you're not going to do anything with that 100 in your calculation. That just says that you can use the graph. If it doesn't say 100 grams, if it says 200 grams, then you would double your solute since they doubled the water. Or if they said 50 grams, you would cut your solute in half since they cut the water in half. Keep in mind that solubility, which is the ability to dissolve, changes whether or not it's a solid or a gas. So solids are going to increase as temperature increases. So all of the lines that I drew on this graph, notice they have positive slopes, so those are going to be an increase in temperature. Let's do a couple of these. If they have a negative slope, those are going to be gases. So gases actually decrease their solubility as you increase the temperature. So the colder gases are, the more they can dissolve into something. And then the next section for this, we did a couple of different calculations. So let's start with molarity. Molarity equals the moles of solute over the liters of solution. So we're just going to remember it's moles over liters. First thing to keep in mind is that they might not say what is the molarity in the question. They might say what is the concentration. So you need to know that these two go together. So concentration is the thing and molarity is the unit. Also, you have to really watch your units for this. You have to have moles and you have to have liters in order to calculate this, and they might not give you that. So they might give you grams, but you can use the periodic table to convert back and forth into grams or into moles. So if they give you grams and ask you to calculate molarity, make sure you convert it into moles first. If they give you information to calculate moles and then ask you for grams, then at the end you would set up a little fence and turn it into grams. Same thing with liters. They might give you milliliters. So just keep in mind that there are 1,000 milliliters in 1 liter. So make sure you convert it into liters before you plug it in. The next equation we did is for dilutions. And the way you would know to use this one over the green equation is because of the number of numbers that they give you in the question. So in the green equation, that requires you 2 numbers to solve for it, and in the blue equation, you're required to have 3 numbers to solve for it. So you can usually figure out which one to use based on how much information they give you in the question. Also watch for the word dilute, so we're going to use this one for dilutions. And capital M stands for molarity. Really doesn't matter what your units are for volume as long as they're the same on both sides. And then the last thing that we did for this chapter is called colligative properties. So colligative properties are ones that depend only on how much solute you add. So it doesn't matter which solute you're adding, which is weird because most properties, it depends on what chemical you're using. But in this case, it just depends on how much. So it's more about the quantity than the quality. And there are several that you need to be familiar with. We talked about the fact that osmotic pressure goes up. I'll write them out and then we'll talk about whether they go up or down. We talked about vapor pressure. We talked about freezing points, and we talked about boiling point. So for osmotic pressure, as you add particles to the solution, osmotic pressure is going to go up. Again, osmotic pressure is the pressure is required to keep osmosis from happening. For vapor pressure, this is the pressure of a gas that's sitting on top of a liquid in a closed container. If you add particles to it, it's kind of like it keeps the liquid from evaporating, so the vapor pressure will go down. You will have less gas in that container. We talked about that if you add ice, if there's ice on the roads and you add salt to the roads, it lowers the freezing point, so it makes it harder for it to freeze because it has to get colder to freeze. And then we also talked about if you are boiling water and you add salt to the water, it increases the boiling point, so it takes longer for the water to boil, but once it's boiling, it boils at a hotter temperature, so it cooks your spaghetti faster. And that is it for solutions.